Okay, here's a video for the Unit 3 assessment review. Solve the systems of equations by graphing. Okay, they're just equals, so you don't have to shade. Y equals negative x plus 3, y equals x plus 1. So if I have to graph them both, make a table. These are both lines. There's no absolute values in sight. They're both line, line. So make sure the y is by itself, and you got your m and b right off the bat. This should be an easy one. Slam dunk. Slope y int. Slope y int. Slope negative 1 over 1. Y int's plus 3. So it's down 1, forward 1. Take a ruler. You need a ruler on these because they have to be accurate if you're going to tell. The answer is the crossing point. You're not shading, okay? They're not inequalities. They're just equations. Inequalities have greater than, less than. Equations have equals. Slope's 1 over 1 plus 1's y-intercept. So 1, 1, 1. I think that's where they cross, okay? Finish out your line, even though you pretty much already know the answer. Okay, so the answer is x is 1, y is 2, positive 1, positive 2. Okay, number 2. We have 2x minus y equals negative 5, and then negative 2x minus y equals negative 1. Here, I'll use my little notepad so you can kind of see better what's happening. You need to use that table. I'll make it on the notepad, okay? So we have 2x minus y equals negative 5, negative 2x minus y equals negative 1. This one, the y is not by itself, and it is not by itself here, so we need to rewrite it into slope-intercept form. So I apply a 1. Well, it's negative. That's not good. So negative, positive, that's just an equal, so I don't have to flip the sign, and then there. So I need to get rid of the negative 2x, so I add 2x, and then I create a 0x over there, and I'll add 2x there. Okay? So line up your equals. You got 1y. Then 2x plus 5. If it's a 1, you can just take it away, because 1y and y mean the same thing. MB. So the slope is 2 over 1. The y-intercept is plus 5. Then I'm just going to go over here and do the same thing here. Okay, once again, same thing. Y has to be by itself. It's a negative, so positive, positive, positive. Minus your 2x, then create a 0x over there, and you're going to subtract 2x from 0x. So we have 1y, and we're going to have negative 2x this time, plus 1. Just take the 1 away. If it was a 3 there, I'd have to divide everything by 3, but it's not, okay? So slope here is negative 2 over 1, and the y-intercept is plus 1. Okay, now I go graph them. So 5, 1, 2, 3, 4, 5, plus 5, then up 2, forward 1, up 2, forward 1. Okay, positive 1, then down 2, forward 1, down 2, forward 1. And they'll cross. And they cross at this point, so this is my solution, okay? So the answer is negative 1, 1, 2, 3. Negative 1, 3. Okay. All right, then the third graphing one. Number 3. We have y equals 2x minus 1, and then 3y equals 6x minus 3. I'll just make it here. Y equals 2x minus 1. So I already have my MB on that one. So slope is 2. The y is minus 1. So I go minus 1, then up 2, forward 1. Okay, and I graph that equation. Okay, funny thing happens in the next part. 3y equals 6x minus 3. So I block the y off, the y side off. Now, it's positive. It's not by itself, but at least it's a positive multiplying number. You don't have to add or subtract. You go straight into your dividing, okay, by 3. Everything in there is divided by 3. So y then equals 2x minus 1. Well, funny thing happens. Slope's 2 over 1, minus 1's the y-intercept. Ain't that the same thing we have? That's IMS, okay? Infinitely many solutions. No solution is when they're parallel, okay? All right, number 4, we will come back to the graph paper once I get to 8 and 9. Okay, I'm going to make my boxes, okay, in number 4 and number 5. So solve the system by substitution. Okay, here are the equations. You have 2x plus 2y equals 38, and then y equals x plus 3. Substitution, you got to find one of the two variables in one of the equations by itself. We're trying to find where the lines cross without the graph. Substitution, you got to find a letter by itself. I think you have one here with your y, okay? And I circle the other side. So I write, that's called your base equation, okay? Then we have 2x plus 2y equals 38 in the non-base equation, and then I replace the y with the expression x plus 3, okay? So we have 2x plus 2 parentheses x plus 3 equals 38. You can put a 1 in front if you want, but you're distributing the 2, not the 2x, okay? So you got your 2x. Then when you come to the 2, you start multiplying. 2 times 1x is 2x, 2 times 3 is 6, and then 38. Okay, combine your x's, so that makes 4x plus 6 equals 38, and then subtract 6, 32. Divide by 4, and we get 8. So 8 is the x solution. Now for the y, look, if you got y by itself, use the one where the y is by itself, because we just replace the x with 8, and y equals 8 plus 3. 8 doesn't have to be multiplied. It would be 11. Okay, 8, 11. Okay, number 5. You're still using substitution unless the directions say differently. You have to be familiar with all 3 methods, okay? Okay, you don't have a base equation. I mean, line those up. Like here, you have the y by itself. Here you don't. But you're going to put the y by itself. You're going to add 2x. Then you're going to make a 0x and add 2x there. So if you don't have a base equation yet with a letter by itself, find a letter that's at least not multiplied, which would be the y. So then y equals 2x plus 3. Now I got myself a base. It's equal to 2x plus 3. So the non-base is 3x minus 2y equals 5. Remember, be box of y, but you got to move the minus 2x out of here. You'd make a 0x and add 2x. Okay, so we're going to replace the y now, since that's the base variable again. So it's equal to 2x plus 3. So we have 3x minus 2 parentheses 2x plus 3 equals 5. Okay, make that 2 plus negative, so we drop the 3x down, then we start multiplying the negative 2. So that's going to be negative 4x plus negative 6 equals 5. Combine the x's, you get negative 1x plus the negative 6 equals the 5. Okay, plus 6 plus 6, that's 11. And divide by negative 1, and it's negative 11. Okay, to find your y, use the one where the y is by itself. Y equals 2x plus 3. Well, x is no more. We're going to put negative 11 there. So negative 11 has to be multiplied by 2, and that's going to be negative 22. And then plus 3, it's negative 19. Okay, and that's substitution. Okay, now number 6 and 7, we're using elimination. Solve by elimination. Okay, 3x plus 5y, or my bad, 6x plus 5y equals 39. This is number 6. Number 7 will be done here. Then 3x plus 5y equals 27. You could go about this one of two ways. You can make them all negatives right now, and that'll eliminate your y's, and you can solve for x first. That will work. You can also do the multiplication. Okay, elimination's where you do the timesing at some point, or you just eliminate here. So 3, 3, 3, 6, 6, 6. So 18x plus 15y, and then 39 times 3. I think it's 117, but I don't know. Yep. Okay, then the bottom, 18x plus 30y, 27 times 6. I think it's 162. Yep. So negative, negative, negative. Now the x's go bye-bye. So negative 15y. And then I add 117 plus negative 162, negative 45. Okay. Then I end up dividing, and I get 3. So y is 3. Okay, now find the x. You use one of the 4 equations. I like to use the original. When I find the final variable, I just like to go up to the original. Y is 3. 3 times 5 is 15, so we have 6x plus 15 equals 39, minus 15, 6x equals 24, divide by 6, and you get 4, 3. So that's elimination. Elimination, you don't look for a letter by itself. You have to make sure the x's and y's and the constants are lined up and the equals are lined up. It always goes x, y, constant, x, y equals constant. Okay, 5x minus 9y equals negative 43, and then 3x plus 8y equals positive 68. Now to go back up here, you could have gotten by with less work if you just went negative, 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 and the y's would have went away. Then you would have solved for x first. Okay, doesn't matter. Okay, more than one way to skin the cat here. So 3, 3, 3. I just like to drop out the opening variable in elimination. That's just me. So 15x minus 27y, negative 43 times 3 is negative 129. Then bottom, 15x plus 40y, 68 times 5 is 340, I believe. I'm going to double check. Yep. Okay, now we need one positive, one negative. But then you got to make the 40y negative and the 340 negative, then you add. Okay, so negative 27 plus negative 40, it's negative 67. For some of you that struggle with that in your head, use the calculator. Negative 67y. Negative 129 plus negative 340. It's negative 469, but if you struggle, you punch it in like that on the calculator. Then you divide. Even I don't know that one off the top of my head, so. Okay, 7. So y is 7, now go find the x. Okay, so 5x minus 9y equals negative 43. Since y is 7, we take negative 9 times 7, negative 63, so 5x, either minus 63 or plus negative. At any rate, you're adding it. Negative 43 plus 63 is 20. 5x equals 20. Divide by 5, you get 4. So the answer is 4, 7. Alright, now back to the graph paper. We have to go find what I did with mine. Okay, number 8. You're taking these two inequalities that are graphed for you. If you're on virtual, Shay should have faxed you that for today. And yeah, so you don't have to graph them. The lines are already there. I mean, minus 2 up 3 over 1, and then positive 3 up 2 over 1. Okay, so we're picking the region A. Pick a point in A. You're going to need a table. 1, 2, 3. Let's go 3, 1. Okay. Okay, so y greater than or equal to 3x minus 2, y less than or equal to 1/2 x plus 3. So again, 1 replaces the y. You can't mix them up. 3 replaces the x. That's 9. 9 minus 2 is 7. Obviously that's false, so it's not A. Now let's go to B. Okay, B. Let's pick that one. Okay. So 1, 2, 3, 4, 5, 6. So 6 for x. 1, 2, 3, 4, 5, 6, 7 for y. Okay. Alright, so y greater than or equal to 3x minus 2, y less than or equal to 1/2 x plus 3. So 7 for y, and then 6 for x. 18 minus 2 is, obviously that's ridiculous, so B can't be it. Now, either C works or we're shading D. Okay, let's go C. I would not recommend picking zeros. A lot of people get mixed up on labeling zeros. I'm going to go 1 for x, 1, 2, 3, 4, 5 for y. Okay. Kind of a crappy problem because A and B didn't work. Okay, so 5 replaces the y, 1 replaces the x. 3 times 1 is 3, 3 minus 2 is 1. So that's true. Okay. Now we put 7 for y, 6 for x. If that's true, you go to the other one, see if you got a true statement there. Half of 6 is 3. 3 plus 3 is 6. That ain't true. It eats 6. It's supposed to eat 7. That's false, so it pretty much narrows it down to D. Boom. Okay. Okay, number 9. Graphing systems. Y greater than x minus 2, y greater than or equal to the absolute value x minus 4. Now, I'm going to go to my pack here. You're going to want to make a table like this, but I'm going to do it on the big paper so you can see what I'm doing. You have to graph it yourself now and do the shading yourself. That's a line, that's a V. Okay, so a line, y's got to be by itself, which it is, MB, easy. Slope, 1 over 1. The y-intercept, minus 2. So down 2, up 1 over 1, up 1 over 1, and it doesn't have the line, so it's dashed. Absolute values, those are V's, so we need the HK vertex and then the stretch, which is found with A. Now, there's no A in front, so I apply a 1, and that's my A. So it's the same as the parent, 1 over 1. So set that up. Now, the H, opposite of minus 4 is 4, and without a K, that's 0. So 4, 0 is the vertex, 1, 2, 3, 4. Then up 1, forward 1, up 1, backward 1. You make it solid because the equal sign's there. Now look at your absolute value. You got the greater than, that's above. Okay, so the truths for the absolute value are all above the vertex, but the line kind of goes through the absolute value V. What symbols a line have? It has greater than 2. So above, now I just do the shading above where the line's at, where the line cuts it. Okay, not that part because that's below the line. Okay, all right, story problems. Let's get your notebook paper here real quick. Okay, number 10, a football game. In a football game, student tickets cost $3 each, adult tickets cost $5 each. The school sold 700 tickets. They made a total of $3,078. How many adult tickets, how many student tickets were sold? Okay. So, adult tickets, student tickets. Now there's 3 units of measurement: student, adult, and dollars. Okay. So you got together, student, adult, and they're measured by the tickets. Then how many units per total per unit? Dollars per unit, dollars total. Okay, now your money total is $3,078. How many units? Well, the only thing we see about how many units is 700. Remember, how many units has nothing to do with the dollars. So you have 700 together. That's going to be X and Y, because those are the 2 answers. Since we have this and this, we don't need this, okay? Okay, adult tickets, those cost $5. The student tickets are $3. So X times 3 is the money total for the students is written as 3X, and then 5Y for the adults. Okay, so you're going to make your system. X plus Y equals 100 equals 700. 3X plus 5Y equals 3,078. Use elimination, okay? Because you have them lined up. Don't try to get a letter by itself. So let's multiply by 3 and multiply by 1. So 3X plus 3Y, 700 times 3 is 2,100. And then 3X plus 5Y equals 3,078. So negative C, negative, negative. And we're always adding in elimination. 3 and negative 5 make negative 2Y. 2,100 plus negative 3,078, I think that's going to be negative 978. I divide each side by negative 2, and that's 489. So Y is 489. Now use some common sense here. You're wasting kind of time plugging that in when you could just take 700 minus the 489 to find the student tickets. 211. Okay. Okay, number 11. Hardcover books cost $3.50 more than paperbacks. $198 was collected from selling 20 hardcover books and 12 paperback books. Find how much of each type of books cost. So now we're not finding the number of units, we're finding what the units cost per. Hardcover cost equals paperback cost equals. So that's what you're finding, but you're going to do your table again. Setup's going to be different because the information's different. So hardcover, paperback, they're measured by books. So how many units? Dollars, and then per unit, and total. Okay, what's total cost down here? Total cost is $198. How many units? So we have a couple of units, 20 hardcover, 12 paperback. You can add those, it's 32, but there's no variable there. So since you know this and this is not needed. Okay. Okay, cost per unit. You don't know anything about the cost per unit. The only thing you know about the cost per unit is that hardcover's $3.50 more. That doesn't mean hardcover costs $3.50. That just means it's $3.50 more. But the nice thing is I don't need Y. I can write both of them in terms of X now. So it's going to be 12X. And here I'm applying the distributed property, 20 times X and 20 times 350. It's going to be 20X plus 70. So 20X plus 70 plus 12X equals 198. So I combine my X's, so that's 32X plus 70 equals 198. Subtract 70, that takes that side to 128. Divide by 32, divide by 32, and 128 divided by 32 is 4. So X is 4. Both the X's are 4, but the paperbacks cost $4 per unit. The hardcover costs 4 plus 350, which is $7.50 per unit. Okay, number 12. Angie and Kenny play online video games. Angie buys one software package and 3 months of gameplay. She pays a total of $65. Kenny buys one software package and 2 months of gameplay. He pays a total of $50. Find the cost of a single software package and the cost of a single month of gameplay. So again, I'm finding the cost per unit now, not how many units. I'm going to know how many units. Cost of software, cost of gameplay. So again, 3 units, quantities. So together, you got the software packages, the gameplay, and I guess that's measured by packages, and that's measured by months. Okay. So how many units? Dollars per unit and total. Okay, the money totals, well, you have 2 of them. You got 65 and 50, so equals 65 equals 50. Okay, how many units? Well, software packages, Angie buys 1, Kenny buys 1. Don't add them and put 2, because you keep them separate. Then 3 and 2 for the gameplay. So that's 4 and 3. So this will not be needed. Cost per unit. Well, we don't. That's what we're trying to figure out. So I'll put X, X, Y, Y. So they're both paying the same cost per unit. So it'll be 1X, 1X, and 3Y, 2Y. And now I see my systems line up. Okay. So 1X or X plus 3Y equal to 65, and then 1X or X plus 2Y equals 50. Now we don't need to multiply. We already have a 1X and a 1X. We just need a positive and a negative. So negative, negative, negative. So 3 and negative 2 add up to 1Y. If I take a 65 and add negative 50, that's 15. So Y equals 15. You don't need to divide by 1. It's kind of stupid. Okay. So the months per game, cost per unit, the cost per month of gameplay is $15. Okay. Okay, software. Now you can't just subtract. You have to take one of these equations and replace Y with 15. So X or 1X plus 3Y equals 65. So now that I have my Y solution, put 15. 3 times 15 is 45. And I subtract 45. I get 20. Kind of don't need to divide by 1, but it's still $20. Okay, 13. Study number 13. Okay, it's different table setup. How many ounces of a 20% hydrochloric acid solution and a 70% hydrochloric acid solution need to be mixed to obtain 20 ounces of a 50% hydrochloric acid solution? Okay. So I want to know how many ounces of the 20%, how many ounces of 70% do I need to mix in this container so that I get 20 ounces of 50%. Now 50 is closer to 70 than it is to 20, so we know the ounces we get at 70 should be more than the ounces we get at 20. So ounces at 20%, ounces at 70%. Okay, your table, but you don't think of it in terms of units, okay? You're not going to put together. You put the lowest percent, then the highest percent, then the middle percent. Now here you're going to put percent, and here you're going to put the ounces. And this is your overall ounces, okay? You really don't have to label the bottom, but if you do, it's ounces of the hydrochloric acid, okay? Now the percent, so that'd be 0.20. I know that's the same as 0.2. I already know that, okay? Just easier to see, but it has the same value. Okay, overall ounces. The only thing about overall ounces is 20 ounces of the 50%, but you don't put it there, okay? That's overall ounces, so 20. You don't know this. You don't line up the 20 down here. That's overall ounces, not of the hydrochloric acid, okay? Okay, now you're like, well, what do I put there? Well, you got to find 50% of 20. Well, that's 10, and that'd be 0.20x and 0.70y. So you have your system. We're going to change the bottom a little bit. X plus y equals 20. Multiply all these by 100 so that the decimals are eliminated. 20x plus 70y. 10 times 100 is 1,000. Now we're going to multiply, use elimination. So times 20 times 1. So 20x plus 20y equals 400. And then 20x plus 70y equals 1,000. See negative 70, negative 1,000. So I add 20 plus negative 70 is going to be negative 50y. 400 plus negative 1,000 is negative 600. So then I divide by negative 50, and y equals 4. Okay. So 4 ounces at the 70%, 4 overall ounces. Now the 20% is easy. You see x plus 4 equals 20. I'm guessing it's 16, okay? Wait a second. I think I misdivided that. I have a problem there. I misdivided that. That is not 4. I don't know what I was thinking. It's actually 12. 12. I knew I was wrong because I knew I had to have more ounces of the 70. Because 70 is closer to 50 than 120 is. Sorry about that, okay? It's probably what you get when you try to do math in your head all the time. 20 minus 12 is 8, okay? Okay, number 14 is a quick one. It's a ratio problem, but it's not like a middle school cookie cutter problem. Ratio of cats to dogs in the animal shelter is 5 to 2. So right now we're going to label that ratio. That's cats, that's dogs. We need a total. 7's the total in the ratio, okay? There are 63 animals available for adoption. How many are cats? How many are dogs? So 63 is the total. So 63 times what's 7 times what's 63? Well, if you divide 63 by 7, you get 9. You take 2 times 9 and 5 times 9. That's 45. That's 18. So the answer is, and it happens that quick, 45 cats, 18 dogs. FYI, a shelter usually has more cats than dogs. Stray cats are common. Stray dogs are not.